what is analytical philosophy? Because for me, philosophy is artsy and very non-analytical. So how do you combine philosophy with analytics? As the CEO of Nixtla, what's your day-to-day like?
One of the most important tasks of a data science or machine learning engineers is not necessarily the implementation, but I think the job starts at the questions that we ask. It's extremely important that we ask smart questions.
Why did you decide to build TimeGPT?
One of the first lessons in entrepreneurship, you have to build something that people need. I think more people are going to be working with data in the next 100 years than they have been working now.
All right, so hello everyone and welcome to the AI Stories podcast. I'm Leiser, I'm a senior data scientist at Artifact and I will be your host. So today our guest is Max Mergenthaler. Max got a Master of Arts in Analytical Philosophy at the Freie Universität in Berlin, and after that he had a few experiences. He worked as a research assistant at Max Planck Institute. He also was an executive director at ProMexico and launched a couple of startups, Orax and Levo, before actually launching Nixtla. So today, Max is the CEO and co-founder of Nixtla, which is one of the most popular library to build time series forecasting algorithms. So this episode will be a deep dive into time series forecasting and into Nixtla. If you enjoy our conversation, please subscribe to the AI Stories YouTube channel, comment, share, and leave a 5-star review. All right, so let's start now. Hi, Max. I'm super excited to have you here with me today. First thing I would like to know is, how did everything start? How did you get into this world of data and AI?
Thank you, Neil. I'm also pretty excited to be here and to have the opportunity to speak with you and your audience. I got started in data in a very eclectic way. As you mentioned, was studying my undergrad and grad studies in Germany, doing philosophy. And at some point, I started becoming very interested in the quantitative or the logical aspects of philosophy. So I started doing more formal logic, model logic, philosophy of science. And then on the side, something interesting happened, namely the first wave of massive online courses started to become more popular. So at that time, I think it was 15 years ago or something, Coursera launched, edX launched, and I started taking some of the first online courses to learn how to program. I remember taking Introduction to Programming by MIT, a course that is still very popular, that teaches Python from the ground up. Back in the day, it was still Python 2.7, not even Python 3.0, but 3.10 now. And I remember experiencing a very particular feeling about being able to give the computer some set of prefix instructions and the computer executing it. And that feeling of making the computer do something was for me a convergence between many things that I liked. On the one side, logic and thinking. On the other side, languages and formal languages. And on the other side, building things. And that's how I got all started.
And so what is analytical philosophy? Because for me, philosophy is very artsy and very non-analytical. So how do you combine philosophy with analytics? I'm very curious about that.
Yeah, that's an interesting question. And to properly answer that question would take us probably many different podcasts. Philosophers, and particular academic philosophers, are very similar to other academics in the sense that they try or tend to adhere to certain school of thought and tend to embrace certain flags. So at the end of the day, it's funny, but academia sometimes is very much like football in the sense that certain groups belong to a specific team and another set of researchers cheer for another team. And analytical philosophy is a term that is generally used to describe a specific type of philosophy that started in the 20th century. that derived from positivism, and then became prominent in Vienna with the logical positivism or the Vienna cycle. And then many of those philosophers were expelled from Europe to the United States, given their Jewish backgrounds. And then a whole set of philosophers started thinking about questions such as what is the nature of science? How do we think about formal systems? Many of those philosophers were also interested in philosophy of logic. And you have some prominent names like Quine, of course, and maybe earlier Wittgenstein and philosophers and mathematicians such as Bertrand Russell. But analytical philosophy is the name that that tradition got, which is a subset of philosophy that is interested in maybe questions that are try to be more formally stated and try to answer questions about science. And normally that philosophy is opposed to what other historians called continental philosophy, which is a philosophy that is interested maybe with more questions around power, sociology, politics, and then you have very classical and powerful thinkers such as Derrida, Deleuze, and other maybe Foucault, French thinkers. That being said, now after many years, I do believe the distinction between analytical and continental is mostly misleading. But for the sake of a podcast around AI, I thought it would be good to use that terminology. Although I want to be very clear for the philosophers out there that I don't necessarily subscribe to that clear distinction anymore.
So quite philosophical from what I understand. So you made quite a big transition to the world of data and AI. You stay in research for a bit, and then you launch a couple of startups before launching Nixtla. What did you learn from those startups, and how did you come to launch Nixtla after that?
Yeah, I guess uh, one of the big transitions for me from philosophical from academic philosophy to more practical things started at my work at the Max Planck. The Max Planck Institute in Berlin has a research group that focuses on experimental psychology, on behavioral economics, or what they also call quantitative psychology. And that group was looking for someone to help them code their experiments in R. And I knew Python, I didn't know R, but the team thought, okay, maybe this person, if he already knows Python, he could easily learn R. And that's when I started really, probably that was my first job where I was actually coding or doing data science for a job. And and I remember it being great. It was also the early days of R, before the whole Hadley Wickham tidyverse. So we didn't use pipe operators. Everything was vectorized. So it was fun. Now looking at all the progress that, of course, Python but also R have made since those days. But again, I really enjoyed the possibility of transforming concepts, theoretical concepts, into pieces of code that then render certain statistical or scientific results. And after that, I became very interested in the power of data science. I think that was the explosion of data science. Probably at some point during those years, DJ Patil became chief data scientist of the White House. The whole term started getting a lot of popularity. And I was amazed by the idea of machines being able to learn patterns. I was amazed and fascinated by the key concepts of machine learning. I remember studying, as many of you or audience have done, studying the Andrew Ng courses and thinking about the possibilities of regression algorithms, classification algorithms, and and I kept studying, I kept reading, I kept doing more courses, I kept hacking around. And during that time, I finished my work at the Max Planck, and I got invited by some government employees in Mexico to lead some research teams in the government. And I started doing a lot of data science. I started realizing the potential that these new tools had for classical institutions such as the government. Right now, it's pretty common for governmental institutions all around the world to employ data science teams to do different sorts of research. But back then, at least in Mexico, that was pretty new. So so I got even more excited about the possibilities, and that's when I decided to start thinking about building my own stuff. So I built a little startup that I normally don't put in my CV. We were scraping Twitter. We were trying to scrape all the data from Twitter and then using natural language processing algorithms to try to identify specific tendencies in the political discourse around Mexico. And I remember building what I thought was a very nice product, which had like streaming architectures, was very efficient in doing the search algorithms. It was based on Elastic on the Elastic technology. It has wonderful dashboards in Kibana. And we went and presented this solution to many different actors. And we got always the same question. Well, this looks amazing, but I have no idea what I should do with it. And and that's where I learned one of the first lessons in entrepreneurship, namely, you have to build something that people need. The product in itself and by itself, and that is something that happens very often to us data scientists. Dashboards by themselves, statistics by themselves, code by itself that flies in the vacuum doesn't really solve a problem. So it's always about this lucky meeting between the solution and the problem.
Yeah, yeah, and I think it's a classic thing. Then when you get into data science, you want to use the latest fancy deep learning algorithms, and you don't really care whether you solve the problem or not. What you want is try those algorithms and test them. And yeah, a lot of the time, simple algorithms work really well, and what matters is whether you solve the problem or not, and not the customers or the stakeholders. They don't care whether you use the latest deep learning algorithms or whether you use a simple regression. What matters is that you get the problem solved. And sometimes it requires a complex solution, sometimes it can be something very simple. But if you build a deep learning algorithm and don't have a problem to solve, then no one is going to be happy. So I guess that's quite a classic mistake.
That is exactly right. And when I started Orax after the government work, Orax was a demand forecasting startup, and we
Okay.
were doing forecasting for large CPGs in the region. And I remember I was invited to be co-founder and CEO because of certain structural changes that happened before. And I came to the company and I saw a lot of the teams building sophisticated machine learning algorithms to try to forecast. And they were using XGBoost and LightGBM, and they were using like very famous algorithms such as Prophet. And the first thing that I did, Neil, was like, okay, that sounds very exciting, but how does this perform against a very basic baseline? How does this perform against, let's say, average or even a statistical model such as an ARIMA? And and that is one of the founding principles of Nixtla. At Nixtla, we do believe that you should always start with a simple baseline and then grow up in complexity. And at the end of the day, in time series forecasting, accuracy is always relative. There isn't such a thing as like absolute accuracy. It's always relative to a certain baseline. So yeah, I agree. I agree with that.
Yeah, yeah, very good point. And the baseline is also, I think, a common mistake that data scientists make. Sometimes they will say, "Oh, my model is very bad. It only has an error. It has an error of 20%." But an error of 20% doesn't mean anything. If human forecast have an error of 50%, then your model might be very good. And if human forecast have an error of 1%, then yes, your model can be quite bad. So it's, yeah, I agree that everything is relative. And so is it during this first, well, or second startup, Orax, is that the name, right?
Mhm.
Is that when you get into demand sensing, into forecasting? And how did you then decide to build Nixla? Was it based on your experience at Orax?
Yes. So in Orax, for the first time, I started dealing on a daily basis with the time series problems. And at Orax, we had two big problems: the forecasting side of things, which was the time series side of things, and the platform side of things. How do we present these results to stakeholders? How do we build a platform so that it can be integrated into the supply chain systems? And I remember that I was extremely interested in the first problem and not that so interested in the second one. So I was very lucky to get introduced to some very talented engineers, and that's where I met Christian and Azul, my two co-founders, and the three of us started working with some other people on the time series part of it. And at some point, I left Orax and became CTO and co-founder of Levo. Christian left Orax and started doing his PhD on machine learning. And Azul kept working on deploying these time series systems at scale. But during that time, we said we should keep building open source libraries for time series because what we realized at Orax is that the existing ecosystem was not enough. So we decided at that time more like implicitly to build the best possible open source time series ecosystem in the world. And after 2 years, that library became, or that set of libraries became very famous. So we decided to regroup. Christian, after his PhD, and I quit Levo, and we founded Nixtla, me, Azul, and Christian. And, and it has been a great joy, like a great ride. After a couple of years, we are now the industry standard for time series forecasting and anomaly detection. Today is an exciting day. Today we got awarded as one of the few companies that won the next big things in tech 2024 by the Fast Company, together with other important companies such as Coursera, Amazon, Arc, you name it. So yes, that's more or less like in a brief set of sentences the
Amazing.
genesis story.
Amazing. Well done for that. And yeah, I didn't mention it in the intro, but I'm personally a big fan of Nixtla. I use it as well in my day to day. I currently work quite a lot on time series forecasting, and I'm a big fan of Nixtla. So strongly recommend it, and that's why I'm super excited to chat with you today. Before we dive into the library, for those who don't know Nixtla and don't know much time series forecasting, even, what's Nixtla? What does it do?
Yeah, so let me first try to define the problem. Time series forecasting is the scientific or the schematic answer to try to quantify the uncertainty of the future. In less philosophical terms, what we are trying to do is forecast a specific set of values based on a past set of values. Those values obviously are normally autoregressive values, but they can also be external or exogenous covariates. To be even more specific, what we are trying to do is let's have the example of electricity. We have certain demand measured every 30 minutes. And we also have measurements every 30 minutes of, let's say, the temperature. And we want to forecast the next day of electricity demand to do some planning around that grid. To do that, we have to do or deploy time series algorithms. But the same holds true for financial series, demand series, IoT series. So in reality, everything that tracks change in the world is a time series. So in some sense, time series are one of the most elemental aspects of the quantitative world. And in some sense, even further, the whole world can be thought of as different time series. Good. So that's the problem. And now, what is Nixtla? Nixtla is the attempt to create tools for Python practitioners and in general for engineers to handle those problems appropriately, easily, and scalable. So we created Nixtla with those ideas in mind to try to create an ecosystem that can be easily used by different practitioners, that is also very scalable and can perform millions of forecasts if necessary in a distributed manner, but also that is composable. We decided to make different libraries so people can decide if they want to use machine learning algorithms or statistical algorithms or maybe neural forecasting algorithms. So in some sense, that is Nixtla. And to put it in one sentence, Nixtla aims to be the go-to solution for time series practitioners across the world.
So can we maybe dive a bit into those libraries? So you mentioned stats, ML, and neural, which I guess is more deep learning algorithms. yeah, how are the tree built? When should I use the stats library? When should I use the ML library? When should I use the deep learning library? What's your conviction on this?
Yes. So when we started Nixla, we wanted to approach the problem in the less opinionated manner that we could. When we started Nixla, there was an interesting debate in time series academia between classical practitioners and researchers pushing the deep learning agenda. And what was happening is that some of the competitions that were used to assess the accuracy and performance of the different forecasting methods, namely the M competitions, had mixed results. Sometimes statistical methods won or statistical ensembles, sometimes deep learning methods won, sometimes we saw classical grading boosting trees outperforming the former two. So there wasn't really a consensus about what is better, when should what be used. And of course, there are certain advantages and disadvantages of each method. One of the main advantages of statistical methods is that they are what we tend to say interpretable. They are
Hmm.
easy to understand in the sense what's happening. Neural networks are famously understood as black boxes or semi-black boxes. And of course, with machine learning models, you can use a posteriori methods such as SHAP to identify like the relation between the different variables and the forecast that you are producing. But what we wanted to do is create a set of libraries that satisfy all the different needs. We didn't want to endorse one single research direction. And that's why we created StatsForecast. StatsForecast is a collection of statistical methods, the fastest and probably best implementation of statistical methods out there. It was heavily influenced by one of our heroes of all time, Rob Hinman, who wrote the Bible on forecasting, and of course the package that goes with it, Fable, in the R ecosystem. So that's Forecast library has different methods, more famously ARIMAS, ETS, methods for multiple seasonality such as the MSTL, but we also have intermittent demand forecasting algorithms such as Crosstoms, IMAPA. We have also included new developments in that tradition as the complex exponential smoothing by Ivan Sventukov, etc. Then we also wanted
On
to
this
develop.
one, if I can add on this one, sorry,
Yes.
before I've tested quite a lot the Auto Arima model and really like it. I think this one is quite powerful because Arima is often tricky to use. Not tricky to use, it's easy to train, but it's difficult to find the best hyperparameters for your problems. And so with Auto Arima, basically what you do is you take an Arima, but automatically finds the best parameters during training. And it's not really an Arima, it's more like a Sarimax model, meaning it takes also into account seasonality and exogenous variables or additional regressors. And so yeah, the Auto Arima model I think is very powerful. I've tested it, and for some use cases, it works well, especially when you don't have much data. Um, I don't know what's your take on this, but for me, stats model work quite well if you've got small data sets because deep learning doesn't work. ML algorithms also don't work well, and so that's when stats model can be very useful. When it's interpretable, of course, as you mentioned, but also when you've got small data sets.
Yes, and classically, that's why those methods were developed for fewer series to try to understand what's happening. And famously, ARIMAs are still being used to predict inflation across central banks in all the world. They even have their ARIMA 11 or 12x, something methodologically that it's like very clearly specified what you should do, so everyone has to can forecast exactly the same. Um, Also important, we don't only offer the auto IMA model, you can also use the auto SES model, the auto ETS model, the auto theta model, which are very useful if you don't want to spend a lot of time trying to find the optimal configuration for those models. Then the
Okay.
second library is the machine learning library, MLForecast. We provide a very efficient interface to the whole family of sklearn models. So you can use everything from linear regression, nearest neighbors if you want, but also very efficient implementations of like GBM and XGBoost. And finally, on the forecasting front, we also have the NeuralForecast library. and that is more the research side of things. There we have many different neural forecasting methods, from classical neural networks and deep learning, from very new proposals such as the CAN architecture that I think was released a couple of months ago. But we have everything from deep AR, the model that was developed by Amazon, the NHITS, which is a model that we at Nixtla published and is one of the most used models out there, classical LSTMs, NLP, transformers, I-transformers, temporal fusion transformers, and also newer architectures such as the TS mixture and some foundation models like TimeLM. And
And so on this side, how do you stay up to date with the literature, read research papers, and when you find an interesting model, you re-implement it, or how do you decide which models you include there?
yes, something very important to mention is that given that Nixla and the libraries that I mentioned are open source, a lot of the contributions that we are getting are also from the community.
Okay.
So we have had one new model, the MFILS or MFILS, that I don't know how to pronounce it, uh, was recently proposed by one very esteemed member of our community. And what happens is sometimes the community members introduce new models, and sometimes what we do is we keep, of course, up to the literature. And if we think something should be included, we decide to include it. Also, sometimes people just ask us to include models, and then we try to include them.
Okay. And then there is also a last library. I tested this one as well with TimeGPT and foundational models. I'm interested. So why did you decide to build TimeGPT? How did you build it? Yeah, can you dive a bit into this one?
Absolutely, Neil. So for us, foundation models in time series are the future of time series. So the same way that foundation models for text replaced all their ways of approaching natural language processing and computer vision problems, we believe that foundation models in time series are gonna be extremely helpful. And the main promise is the main idea behind a foundation model in time series is that you can train a very large model on a very large data set and then use that to forecast new domains that the model didn't see in a zero-shot manner, or using fine-tuning and just improving some small details of the model. And that idea is extremely powerful because on the one side, you don't have to train the model, which means that, which has the following advantages. It's a lot faster. You don't have to spend time training the model. You just do forecast. On the other side, you don't have to build an entire pipeline of thousands of lines of code to try to prove different models and evaluate different architectures and evaluate different families to try and then choose or ensemble the best ones. So it's an out of the box solution. And, and that's what we decided to create TimeGPT. We wanted to be the first company out there to show that foundation models are possible in time series. And 1 year ago, we published the paper. We even before we released the demos with different practitioners, and that's also our commercial product. That's very important. Like all the other libraries are open source, and you can use them for free, fork them, copy them, do whatever you want with them. They're MIT. TimeGPT as a product is commercial. That means that you can subscribe to our dashboard, create an API similar to Anthropic, OpenAI, or other AI companies, and then you get an API and can start doing forecasts out of the box. We also offer an enterprise version for large customers that don't want to send data over the internet.
And so how do you train it? You train it on lots of time series data, and you train it to predict the next data point, right? Do you add exogenous or external variables as well? How does this work?
Yes, so what we did is we first scraped as much data as we could from the internet, very similar to what BERT and GPT did. And then we trained different architectures and saw what was the best, and of course, different configurations. And yes, we do support exogenous variables. How exactly we are supporting them is still a secret. It's part of
Okay.
the trademark, but yes, you can. TimeGPT supports off the box point forecast, probabilistic forecast, multi-quantile forecast, exogenous variables, anomaly detection, cross-validation, and explainability features.
And what's your recommendation? I mean, do you think that TimeGPT is better than traditional algorithms like boosting, stats, deep learning? Or do you think that it's not yet the case, but it will become the case? What's your vision on this?
So we have performed extensive benchmark to try to answer that question. And in our benchmarks, we do see TimeGPT outperforming on average all of the above solutions. And given how much easier it is and how much faster it is, I would recommend everyone to at least give it a shot. By the way, we offer free trials for everyone and big discounts for academics and researchers. So we would definitely encourage everyone to give it a shot. Uh, that being said, we're still seeing cases where, for example, for very high frequency data, grading boosting trees outperform TimeGPT. We must remember that this is TimeGPT 1. We're still on the early
Mm-hmm.
stages of this, so I do think that this is gonna become even better and better and better. But we are amazed that it is even this early version, it is outperforming classical models, and it is being used in production by companies across the world that have replaced their entire forecasting systems with TimeGPT,
Okay,
literally
wow.
hours and hours of compute with minutes of, not minutes, seconds of inference.
Yeah, and I mean, I've tested it, and I think it's a very strong baseline. So definitely worth trying. I think it's great if you've got very little time because, as you mentioned, it's fast and it's super easy to use. I think in 5 lines of code, you've got the predictions and confidence intervals as well as you mentioned, and other things. You can use exogenous variables. I still like stats and boosting algorithms for interpretability, and because I guess as a data scientist, I like to understand a bit more the models. So, do you think you will add an interpretability layer to TimeGPT at some point? Is that even possible? What do you think?
Yes, I don't know when you tried TimeGPT recently. I think 1 or 2 months ago, we included a whole package or a whole framework, I mean, around explainability and interpretability based on SHAP values.
Oh, nice.
And and now you can, of course, that interpretability entails exogenous variables. We are
Hmm.
still not reflecting any interpretability on the near autoregressors, right? Uh, but yes, we are working on interpretability. We're very happy about the possibility that you can run now explainability reports in 2 lines of code to understand the influence of your exogenous variables. And in the future, we want to go even further into that field. And I think even better than explainability, and that's something that we're working on, is counterfactuals or what if scenarios. Namely, it's interesting to understand, okay, what is the influence, what was the influence of this variable to this forecast? But it's even better or more exciting to try to understand what would happen in the future
Hmm.
if I change these variables now. To give an example, what would be the sales of this particular item if I run a 5% discount promotion, for example?
And is this a secret, or do you try to do this using SHAP value? Do you use other methods? How do you plan to do that? Because that's
No,
a
that's that. I hope it was a secret. The answer is there is no secret because we're still working on it. So we haven't converged into one way of thinking about those
okay.
casual interactions. But I can definitely tell you that using shop values alone for what if scenarios, I think wouldn't be a good enough solution.
Yeah, because for me, I mean, if you've got performance and you've got explainability and you've got ease of use, you basically won the game of forecasting. I guess there is also ease of deployment and costs, but I think companies will probably be happy to pay if they've got ease of use, explainability, and performance. So combining those three is often very difficult, and that's what we see at the moment. Deep learning algorithms and boosting algorithms have more performance, stats have more the interpretability side of things, and so combining the two is not always easy.
Absolutely. Absolutely.
And so going back a bit to what you mentioned, so you talked about TimeGPT, but lots of things happen in Nixla as well. For example, in other libraries, you mentioned confidence intervals, you mentioned being able to add exogenous variables to forecast multiple time series. So why do you think that people use Nixla? What makes Nixla better than other tools up there? Why do you think that people like Nixla so much?
Yeah, that's an interesting question. It's I I think the we have a pretty interesting ecosystem, and when we started, and probably still today, the most downloaded library for all of time series is Facebook Prophet. It's a library that was developed, I think, 5 or 6 years ago by
Mm-hmm.
some people at Facebook, prominently a good friend called an investor, by the way, called Sean Taylor, and others, and that package became incredibly popular. It's used in many different settings, and it's funny because many times, not always, but many times, it's incredibly wrong. It's incredibly bad, but it produces very beautiful looking graphs. So I think what happened is a lot of people went to that solution because it was like, it's Facebook, so it must be good, and it looks nice, so it must be good. And the reality is that it was very bad. And if you look back in time when we started Nixla, we started making a name ourselves by benchmarking our implementations with other libraries. So some of the first posts that we did on LinkedIn, Reddit, etc., was comparing basic ARIMAs with Prophet and showing how an ARIMA could outperform 20 times faster and 30% more accurately a Prophet model on some benchmark data. And I think that started a whole tradition in Nixla to try to build very efficient, easy to use, fast algorithms. And over by benchmarking, comparing ourselves to Amazon, comparing ourselves to different implementations, we showed that our code is better. I think another thing that is very important about Nixla is that if you look at the other top libraries and projects in the world, like Darts, SK Time, Amazon Forecast, or Glue on TS, they all use some in some way or another Nixla, but we don't use necessarily their code. So we are also like a library that is empowering other libraries. Uh, that being said, I mean, some libraries have been there for, I don't know, 20 years or something like that, and they are still very common and used. So I I guess I don't know what the community likes us more. Maybe I would like to think because we are better, we are easier, we are faster, but but I don't know. Go ask them, why do you like StatsForecast? Why do you use StatsForecast and not another one?
I mean, I think I can give you a few answers then. Um, why do I like? So one thing that's very powerful is this pipeline of models. So you can have 10 models if you want, fit all of them in one go, and then get the forecast for all those 10 models. And so when I start a problem, I would take 10 models, train them, and then get predictions, evaluate them, throw away the ones that are very bad, keep the ones that are great, maybe fine tune them a bit more, and then keep the best one. But it's so easy to have this pipeline with tens of models. That's one thing that I really like. Um, Other thing is for the MLForecast library, the lag feature where you can create lags very easily. So to give context, lags are features based on historical data. Many people will be familiar with this, but if not, for example, it would be um, yeah average. So you talked about electricity demand. So what was the electricity demand last week, last month, last year, the average of the last 2 weeks, and things like that. And you can really building lags is not super difficult, but if you want to build like difficult lags, it can take some time. And with Nixla, it's really like one line of code, so super super simple. So that's another thing that I like. Maybe to add another one, you mentioned confidence intervals using conformal predictions. So you add something to the training pipeline and you get confidence intervals, which is amazing. Uh, yeah, so those are those good reasons? Did I convince you?
You heard it yourself, people listening to this podcast. Those are great features by Nixtla. And I also think recently there was this competition by another important figure in the field called Nicolas van der Put, and he did this new time series competition called the VN1 forecasting competition. And we were very happy to see that I think 80% or something among the top 10 submissions used Nixtla to, or some of the libraries. So yeah, I also think that is one reason that the community loves us so much, that we give them a lot of freedom. If you want to use StatsForecast, use StatsForecast. You don't even have to install MLForecast. You can install just StatsForecast or NeuralForecast. And on the other side, we're very transparent. If you don't want to train your own models, go and use our paid solution. And if you like it, use it. And if you don't, use the other ones, or use both and create an ensemble. So I think empowering users and putting users at the center is one of the things that we have been doing quite successfully.
Yeah, and yeah, what's good is really those features that you build across all libraries. So being able to compare models, confidence intervals. There is also, I didn't mention, but cross validation with time series, which can be tricky to implement and is super easy with Nixla. Um, what's the feature that you implemented and you were like, ah, wow, I'm super happy that we have this feature now? Is there one that you're super proud of?
I I think I am personally the proudest about TimeGPT, because TimeGPT, in my opinion, marks a milestone in the history of time series. And of course, many different research labs were working on this idea. And I think 2 days after we published our paper, put our published paper in Arvix, some labs followed, and then a couple of months other labs followed. But it was, for me personally, an amazing feeling to see that a team back in the day of 5 persons, me, Azul, Christian, were able to create something that will become a small, very small part, but a small part in the history of modern machine learning for time series. So I think that I'm very proud about having that idea together with Azul and Christian, and being able to implement that idea with them, and showing the world that the transferability in forecasting is indeed possible.
Do you think that that's the future of forecasting? And are traditional stats and ML algorithms, well, will they be dead basically? Because
I I do think it is the future, and I do think that we're gonna see a very similar trend to what we are seeing in computer vision and natural language processing, where more and more problems are being solved by those models. That being said, I also think that we're going to see smaller foundational models or specialized foundational models that maybe focus on very high, very fast forecasts instead of maximizing accuracy, something like the GPT minis versus the GPTOs. Uh, but I don't think that necessarily means that the other methods are going to die. The same way that probably if you want to count the R's in the word strawberry, you shouldn't use GPT-4 because it always gets it wrong. maybe, maybe don't always use TimeGPT for specific forecasts. But I do think it's the future. And I do think it's the future because at the end of the day, we're working on that. But if we have scaling laws of time, if scaling laws hold true for time series forecasting, and we believe they hold true, then then it's going to become clear that foundation models trained by ourselves at Nixla or other companies or other research labs are going to make the life so much easier for practitioners that there shouldn't be a reason not to use them.
and maybe I dive into philosophical questions, but that's good because you studied philosophy. But will we need data scientists then? If you just plug the data into your model and get forecasts, yeah, will we need data scientists?
Yes, I think definitely yes. And I think maybe one of the most important tasks of data science or machine learning engineers is not necessarily the implementation, the mechanical implementation of algorithms and the production of certain results, as we discussed in the beginning. But I think the job starts at the questions that we ask. It's extremely important that we ask smart questions. So yeah, if you give TimeGPT something, it's gonna forecast something. But if you are forecasting things that maybe are autocorrelated, if you are introducing leakage into the data, if you are forecasting something that cannot be forecast, like trying to forecast a coin flip thing, then then by definition you're building bullshit. And it doesn't matter if you have a hammer or if you have a chainsaw or if you have statistical methods or deep learning methods. If the project you are building is by design wrong, then the tools don't matter. And that's where I believe that the human in the loop is extremely important, because at the end of the day, these things are just tools, and the projects that we built around them, those are still, at least in big in a big sense, human projects. So yes, I think we would need even more data scientists. Let me make a prediction. I think more people are going to be working with data in the next 100 years that they have been working now.
Yeah, I think that's probably a good prediction. I agree with you. You mentioned like data leakage. We talked earlier about strong baselines, or you need a strong baselines. What are the things you need to build a successful forecasting problem? What do you think are the key things that you should pay attention to as a data scientist, or common mistakes that people make? Yeah, what are those things?
Yeah, I think the first thing is you need to define the problem correctly. What specifically are you trying to forecast and why? Then you should make or spend at least some time thinking about whether this problem is a good problem for forecasting techniques. So this is a classical example, but you shouldn't try to approach something as a classification problem if it's a regression problem, or a regression problem if it's a forecasting problem with time sequences very well defined. So I think that's important. And after that, I think you should think a lot about the utility function that you are trying to optimize. Why are you forecasting this, and why is it important? And classical examples are, for example, demand forecasting. In demand forecasting, you can try to forecast the mean or do point forecast and try to maximize accuracy for those predictions. But that is not necessarily the best approach. There is this problem called the news vendor problem, where maybe being a little bit above the actual values is always better than being a little bit below. That is because if you have more inventory in stock, the waste of the inventory is less expensive than the lost sales that you would have if you don't have your inventories stocked all the time. So those are examples where you should really think about like what you are trying to do. Are you trying to maximize a pure metric of accuracy, or are you trying to maximize inventory availability so you have more sales? And that's very important. Then another problem that we see, and I don't know how to approach this, is to understand that very often forecasts are very political, in the sense that if you are doing retail forecasts, then if your forecast is too low, then probably the people above you or the business people are going to tell you this cannot be the case, the forecast has to be bigger. And then you have a second order problem, namely that sometimes if you put very large forecasts, then maybe the organization strives to get those forecasts and therefore becomes those forecasts a reality. So there's always this weird philosophical thing that the future hasn't happened yet, and that we, by our actions, do influence it. So that's more like a philosophical comment, but that's also something that you should consider. Maybe it's not always about accuracy in itself, but relative accuracy, what if scenarios, diff in diffs. So think about those things when creating forecasting pipelines.
Yeah, and then just to complete, I mean, fully agree with all the things you mentioned, and I think what we discussed before is also relevant. So one, making sure that your forecast has a lot of ROI and that it will be useful. Don't just predict things for the sake of predicting things. First, ask yourself, is it something that's going to add value to my business. And then the baseline stuff, like you need to know when your model is good enough. And as you mentioned, this is a relative problem. You need to compare it to something else. Otherwise, you might keep trying to optimize a model that's already very good, and you will lose a lot of value because you won't deploy it in production for a year because you want to optimize it. So you really need to have a strong baseline and basically think a lot about performance. What does a good model actually mean? Which also relates to what you mentioned, having a good metric, I guess.
And and maybe just to complement on that, there is a very classical measure that is used among forecasters, a very simple one called forecast value added. And basically, what you have is the accuracy of your model versus the accuracy of the baseline or what was done before. And then you take some measure of value or costs. Namely, if the new forecast costs you $100,000 to run because you have to use GPUs and 4 PhDs in your company versus an ARIMA, and it costs you maybe $1 to run, and the improvement in accuracy is only 1%, and it doesn't reflect, then of course you don't have a positive forecast value added. You have a negative. You are not adding value. You are decreasing value to the forecast, and that's also why maybe TimeGPT can be interesting. I think right now the basic subscription is something like $100 a month, and the basic one is free. You can get, I think, 40 predictions a month for free. So that is very very much for a lot of people. And if you want to go up into API calls, you can use it. But go and try it, because I think you are gonna be hopefully impressed by the accuracy and the ease of use, and hopefully the value that it is creating to your projects. And while this is running, you can go and drink coffee and tell your bosses that the model is still running.
And no,
No,
definitely. I
don't do
mean,
that. Don't do that.
yeah, you could relax a bit more. I mean, I've tried it. I really liked it. Still think stats and MLForecast at the moment are worth it. But I mean, you might be right. In the future, LLMs might replace everything, and it's good and also scary at some point, because if it works for forecasting, it can work for other problems like credit scoring, fraud detection. But yeah, that's another topic. I wanna focus maybe less on time series, more on you, like as the CEO of Nixtla. What's your job? Where do you see the company going? What's your day to day like? I guess it's less about code and more about business. And what's the future of Nixtla?
Yes, we at Nixtla defined our creed, and we published the creed. You can go, if you go to Nixtla, to github.com/Nixtla/Popol Vuh, you're going to see our creed, and we define the mission, or the goal of the company to maximize the utility function of our users, our customers, and our colleagues. So the idea is that in a Rawlsian min-max way, we try to make those three groups of people the happiest possible. We do believe if that is the case, then commercial success will follow, and therefore Nixla will be a commercial success. And my job as a CEO is to try to always think about maximizing the utility function for those three groups. So in less philosophical terms, what I try to do is organize myself and the team as best as I can, and sometimes remove myself so I don't become. Sometimes the best way to help is not to interfere. Uh, Also, of course, I am like daily concerned about how to grow the company. Also, my tasks are building relationship with investors, trying to raise money for the next round. And I think the future of Nixlab is to really become the absolute go-to solution for time series forecasting, both free and paid. So we do envision a world, and that's our vision, where everyone uses Nixla, and if not directly, maybe under the hood. So we do envision a world where maybe this app that we are using to record the podcast can forecast the demand of their different podcasts, so they can allocate infrastructure correctly. and that the people that are like selling every small cup of coffee inside their their point of sale machine use time series algorithms to be more efficient. So we do see a world where foundation models connect and make everything more efficient, and we hope that Nixla plays an essential part of that world.
Do you still have time to code?
And no, not at all. And also, I think it's good. I am the worst code, probably the worst coder in the company. So I think it's good that I don't code that much and leave that to the very talented set of engineers that we have. That being said, sometimes I code very small things or do very small PRs.
Okay, great. To stay in the loop, I guess, and exercise a bit.
Yes. Right now, probably I spend more time installing the environments and setting up the whole set of libraries that for the small PRs that I have to run. But yes, it's fun to see the projects directly.
You write the print error message thing. That's what you did. That's your
Oof, no,
contribution.
if someone would push something with print error, that would be not accepted. We try to use optimal error handling, so we don't print error, we raise exceptions, and then if it's an error, we raise the error. But no print errors, please.
Well, this show is called AI Stories. It's mostly your stories. We dived a lot into Nixla, but we understood how you arrived where you are, what you're doing today. So, one last question before we finish this episode is one advice. If you just had one advice for someone to progress in their career, what would it be? Just one advice.
Mm. These questions are always very easy because if I had one advice, only one advice would be to don't listen to people that give you only one advice. The world is complex, and normally one set of advice, only one piece of advice is never going to be sufficient by definition. One piece of advice is always wrong. I do think, and maybe that's the inverse of the question, that understanding the complexity and the multi-causality of our situation is important. So I don't think that focusing on one single thing is important. I think trying to really embrace the complexity of our reality, both personally, mathematically, professionally, is important, because otherwise, by just focusing on one metric, that's the definition of always being wrong. There is a scenario, a very common scenario, where the mean is the worst possible metric between 2 points. So don't focus on one advice only. That would be my advice.
Well, Max, thanks a lot. It was great to have you on this episode. Have a great day in the US, and yeah, hope to catch up very soon.
Thank you so much, Neil. It was a pleasure talking to you, and hopefully this is helpful to your audience. Maybe one last set of comments. We have a Slack community. If you are a user of the Nixlaverse, please join. We're always happy to help there. We're very active on GitHub. If you have any questions, raise issues, raise questions, even if it's your first one, don't be afraid. We're always very happy to help practitioners like yourself. And if you're starting a company, I recently also became a scout for a VC firm. So please ping me, and I'm also happy to help you in that journey. Thank you very much, Neil, and thank you everyone listening.
Thanks, and we'll definitely share lots of links in the descriptions about the repo, TimeGPT, and other repos. So yeah, make sure to check those out as well. Thanks.